Alright, another video which I have not prepared in my mind at all. So here at the tail end of 2022, between Christmas and New Year's, I've been working on a few projects in my lab. One is that I restored what I thought was the unrestorable Heathkit IM-105. I've already done a video on another one of these in my collection. This one was in really bad shape, but I spent pretty much all day yesterday on it and actually got it all reconstituted and working quite well. I'll probably turn around and try to sell it on eBay. And meanwhile, I'm taking another item here that was given to me. This is a Heathkit IMB-18. I don't know what the IMB. Oh, that's because it's advanced schools. This is the like a correspondence course or something version of the IM-18, which I also have a video on. The controversial battery eliminator circuit I designed for that, which a lot of people like and a lot of people think is really dumb. Anyway, I got this one. It was given to me, and I think it's, even though it's much abused, it has, I think, cigarette stains and or burns on it and stuff, but I thought I'd try to get it working. For this one, I've got a commercial battery eliminator that somebody on eBay sells, and I'm just going to give it a quick cleanup and install that thing and replace the power cap, do a couple things like that, and see if it's something I can turn around and sell. But the subject of today's video is I have bought a Heathkit AA-18 monaural audio amplifier, which I bought just because I was always curious about it. I'd wanted to buy one when I was a teenager and never really thought I had a use for it, but I'd still always wanted to build one. Well, I bought one on eBay that's going to need just a little bit of restoration, I think. And I decided to put it on my bench so I'd have a handy audio amplifier and speaker when I'm testing out circuits and things. In the past, I've dragged a set of computer speakers around, powered computer speakers, for that purpose, but they're kind of unwieldy, and there's no good place on my bench to set them up permanently. So I got this bright idea that the AA-18 can go. I'll move my old capacitance box out of the way. I have a better one from Heathkit. This is like an old ICO or something. Yeah, it is. And I can put something up on top of this generic multimeter, and that's about the width of the AA-18 and also the depth. It doesn't quite go back, so it'll sit up there pretty nicely, I think. And then on top of that, I'm going to build a small speaker enclosure to go with the amplifier. And to that end, I have a couple of these speakers that I bought once from Amazon. They're really cheap, but they're of a decent size, and I figured that a couple of these would probably be all the speaker that amplifier would ever need for my purposes anyway. These are little 4 ohm 5 watt speakers. The amp itself is rated for 3.5 watts, but I don't recall that it's rated for 4 ohms. I think 8 ohms is probably the minimum. Anyway, I have a couple of these speakers. They've been knocking around. I think I'll just use them up. But if I put them in parallel, then it'll be 2 ohms, which is definitely too low for the AA-18 amp. So I figured I'll just put them in series. You know, the volume will be less than it would be if they were in parallel, but at least I can get these stupid things out of the way and into some practical application. And I figured that push some stuff around here. I made a quick scale drawing of the AA-18's front panel. and just sort of verified that it definitely will fit on top of that meter. It's easier to visualize things that way sometimes than just dragging a ruler around. And then these two speakers, if I build a shallow, kind of like a normal speaker cabinet tipped over on its side with these two speakers side by side, there should be plenty of room for them in there without it getting really obnoxiously tall. So that's my real project for the day. So I'm going to tell a little story here about my teenage years and my beginnings with Heathkit. I already have a video that's quite a few years old now on a Heathkit electronic project board that you could turn into various things by connecting components in different ways, that I had when I was probably just first year of junior high school, or middle school as it'd be called now. And then when I was in high school, a number of other kids who were interested in electronics or stereos or what have you were starting to look at Heathkit catalogs and, you know, salivating over them. And although by my senior year I'd built a lot of Heathkits, almost all test equipment, as part of the outfitting of the electronics lab at the high school they were just putting together, I hadn't built any Heathkits of my own except for that one project kit in my first junior high year. So one of the kits I almost pulled the trigger on and almost bought. Now this is a 1969 catalog, but it's, I think, the next catalog that came out after this particular kit was announced. And it's here in the stereo and hi-fi section of the catalog. Here they have all of their lower priced stereo and hi-fi components, all comparatively low end and inexpensive. And the lowest of the low was this AA-18, just a monaural amplifier. They originally rated it at 4 watts. I think it was really more like 3.5 watts. But pretty flexible. It had a stereo headphone jack on it, so you could at least listen with stereo headphones. It just had a simple tone control that adjusted or favored bass and treble. And it had a volume knob, and that was it. No balance, of course, because once again it's a mono amplifier. It had a single RCA input on it, which could actually be used for quite a wide range of things, like crystal phonograph cartridges, microphones. I think you could even plug like a guitar into it and use it as a small guitar amp. Although its primary purpose was to connect to the output of tape decks and other things to boost them to get you know, a single speaker. And it was pretty flexible in the sense that it could be used with any reasonably high efficiency speaker between 4 and 16 ohms impedance. As they say here, they still list it as new even though it was announced the previous year. It's a 5 transistor, 2 diode circuit, delivers 4 watts music power. Drives high efficiency speaker of 4 to 16 ohms, accepts ceramic phono cartridge input, microphonic AM or FM, or monophonic AM or FM tuners, or tape recorders. Again, it would work with certain types of microphones. And even though it doesn't mention it here, like I said already, supposedly you could use it as a guitar amplifier. Although the jack wasn't the right type. Can be wired for 120 or 240 volts AC. An ideal amplifier for adding background music to a den or rec room. Excellent frequency response, although it's not specified what that is. Going to the 1970 catalog, it's already moved to a page of really just a couple of options. the AA-18 and what was essentially Heathkit's next step up, a little more powerful and stereo with actual bass and treble tone controls. But it's still there, it's still affordable. So around the time of my senior year of high school, I was ready to pull the trigger on buying one of these AA-18 amps, and I couldn't think of a good use for it, but I really wanted to buy one, and several of my friends had purchased their own, but stupidly, because they didn't know enough about what they were buying, and they envisioned that these were like either very powerful guitar amps that they could use on stage instead of maybe just for practicing. They didn't understand the low power, or they overlooked the fact that it was mono and just assumed if it was an amplifier it must be stereo, and they could use it to put together their own bedroom stereo systems at home, only to find out that it was mono. Some of them never even got built. They just put them on shelves or sold them to some other kid. Anyway, so I never did buy one. Common sense prevailed, I guess, and I never bought one, although I always kind of wished I had in a way. Now, when I do my series of documentary videos on Heathkit test equipment, I almost always start off by showing Chuck Penson's excellent book on Heathkit test equipment products. Chuck also has other books. He has one on Heathkit hi-fi and stereo products, that's this one, and another one on their ham radio products. In addition to a very fine book on the Titan II ICBM, and that comes from his long curatorship of the Titan Missile Museum in Arizona. Anyway, so looking at his book on this hi-fi and stereo components, flip to the correct page in the large chapter. I'm definitely going to have to rebind this book. This one's even stiffer than the test equipment book. Hard to get the pages to open all the way. Anyway, so there's the AA-18. Here it's listed as a 3 1/4 watt monophonic amplifier. 1968 to 1989. Now they show a price of $19.95. I think that may be, I don't know if that was the price when they were starting to discontinue it, or if that was the price when it was first announced. But the two catalogs I just looked at wanted a few bucks more than that. So let's just look down at what we have there. As it shows here, just like I said before, really all it has is a single RCA jack on the back for the input, but it's a pretty forgiving input. Simple screw terminals for the speakers, that was common at the time, even on powerful amplifiers. The stereo headphone jack, I don't think they actually say it's a stereo headphone jack, but I'm pretty sure that it is. Volume and tone controls, power switch, and a power lamp. And there's a internal view. Chuck says, "The little amp that could. The AA-18 has the distinction of being Heath's most enduring audio product. Introduced in 1968 as a solid-state replacement of the tube-type 3-watt AA-191, the AA-18 had a place in the catalog for 22 years, right up until the end. The circuit uses 5 transistors and 2 diodes. Its single input will accommodate almost any kind of source, from a ceramic phono cartridge to a line-level device." And here's some actual specifications. I don't think those came from the catalog. They probably came from the manual. Output power 4 watts, IHFM dynamic power, or 3.2 watts. Heath continuous music power. Frequency response plus or minus 3 dB from 25 Hz to 100 kHz. Total harmonic distortion, blah blah blah. Output impedance 4 to 16 ohms. Input sensitivity 250 millivolts. Input impedance 125K. Hum and noise minus 65 dB. Treble cut minus 22 dB at 15 kHz. Bass booster cut not specified. Damping factor 10, whatever that is. Power requirements 120 or 240, 50, 60 Hz, 5 watts. and the transistor complement here. It uses a 2N3638 and 3393, and then the power transistors for the push-pull output stage, MJE 371 and 521, and 2 unspecified silicon diodes. So I bought one on eBay. I've been looking for one for a while, and usually when these turn up, they're either just really trashed or somebody has heavily modified them, and I wanted one that was more virgin and just like Heathkit designed it. So 2 of them actually showed up at the same time. One of them in Canada, which actually looked a little nicer than this, but they didn't say anything about whether it was working or not. And the tariffs and the shipping were pretty pricey, even though the sale price was lower. And then there was this one that came out of some sort of electronics thrift shop in Missouri, I think, and they didn't give any description at all, other than they just gave condition as used, and the eBay description of used, when you open it up, says that the device is used but working. So I don't know if the seller just said, well, it looks okay, we'll just say it's used and not read the fine print. But it came through in what I would consider to be almost certainly non-working condition, and kind of dirty. Looked better in the pictures. Maybe they had more than one. But it does seem to be pretty much intact. I've taken the lid off already. I'm going to have to repaint this. And let's take another look at the front panel. It looks like it'll clean up pretty well. Somebody put a Dymo label on this. I can't quite read what it says, but I suspect that, I think it says night hours? No. I don't know. Something ending HT and starting the next word with an HA, something. So they obviously had a Dymo label over this, and this is what you usually get when those go bad. The adhesive in between the letters leaves a residual trace of what the letters were. So they probably had this in, the office of a restaurant or a store or a shop, or, some sort of business or something where, probably it provided a little sound for some background stuff, or maybe they amplified a microphone to, operate a few speakers around an office or something, some application like that, which would not be out of line for the, intended purpose of this amp. Anyway, it does seem to have an actual stereo amp on it, and it's driven through a couple of 100-watt or 100-ohm resistors, so from a common source, but you can see that one of the speaker wires just goes down there, and right next to it on the circuit board are these 2 100-ohm resistors, and then from each of those you've got a lead going up to the left and right jacks on, or the left and right pins on this 1/4-inch headphone jack. So they are driving a stereo headphone jack, but with a monaural source. But they're doing better than just wiring the left and the right together, is my point. And then the black wire to the speaker terminal is the same black wire going to the headphones. So anyway, the jack looked kind of grody inside, so I've dug through my junk box and found a nice Switchcraft headphone jack that'll fit the hole, and I'm going to put that in instead of this one. It had a fuse which was not blown, but it's one of those that's you can't just replace it, you have to unsolder it. And anything like this that I do any restoration on, I put in a proper fuse holder. If it doesn't have a fuse, I add a fuse holder. I think I'm going to mount it just over here and then run the wires over to it, so you don't have to monkey with this stuff. And the capacitors, there's this 10 microfarad 15 volt electrolytic down here, which was just floating around. It looked like somebody actually cut a lead on it. And then this main power capacitor is rattling around. It doesn't look like it was cut. It looked like the lead actually just broke from fatigue. That's a pretty big capacitor to have just held by its leads and allowed to bounce around like that. It may have been working when the seller listed it, and then in transit, you know, it finally gave up the ghost from just vibration and transportation. And these speaker terminals on the back look fine, but this RCA jack looks very worn and looks kind of corroded on the outside. So I'm planning to do a partial replacement on that. I haven't figured out exactly what I'm going to do. Probably I'll use just a simple RCA jack and then put it onto the same bakelite insulator, or I'll make a new insulator and mount it on there. But I am going to replace this jack with one that's in a little better condition. I did check the neon bulb out already and it works, so I don't have to replace that. And this capacitor doesn't look that great. Oh, by the way, this one here is starting to bulge, so even though this capacitor, I'm replacing it because it's just broken off, but also because it's clearly met its match in terms of years and just use. And then I'm going to go in and replace the other electrolytic capacitor down there, and then this one that's a radial style. As it turns out, I happen to have in my new parts bins replacements for the two small ones, and this guy here has the same ratings as this one, so the pinout or the lead spacing isn't going to be optimal, but it'll perform the job. But I didn't have anything that was a good choice for this. It's 40 volts. I have some 2000 microfarad electrolytics, but they're not 40 volts. And I could do something half-assed, like put two in series or something to get the voltage, but no. I had a DigiKey order going already. I just added capacitor to that. The pots are probably okay. Hopefully I don't need to replace those. And I think most likely the transistors are okay. Hopefully that, you know, they're not bad. Hopefully it's just this other stuff. So I've got to start on it, but I have to wait until my DigiKey order comes in before I do much more with this. I may still spend some time cleaning the grunk off the paint, some adhesive remover on there. One nice thing is, I was thinking, oh, it's going to be a pain. I'm going to have to remove these transistors off their heatsink pads and all that in order to get at the back of the circuit board, but Heathkit helpfully put a hatch on the bottom of this one. It's the only time off the top of my head, oops, come on, that I can remember them doing that. So that should give me access to the whole bottom of the circuit board for replacing any components or taking measurements or what have you. Yeah, look at that. Very nice. Not a great job of soldering on there. Some things are barely soldered, but probably good enough to work. Anyway, so I'll get back to this and shoot some more video when I get more stuff done on it. There's a better view of that leaking and bulging 2000 microfarad 40 volt electrolytic. So I've got that off the board. And if I did things correctly, I should be able to lift these guys out of there, but not quite breaking free yet. Pretty big comparison in size between these old 1970s caps and modern ones. This is a Nichicon 1000 mic at 25 volts, same specs as this brute, which also has what might be the beginnings of some leakage on the bottom. Alright, so I've got this guy, and this guy in there now, but I still have to wait till tomorrow to get this capacitor. I think I'll address the jack here and probably also the mechanical part of this guy here, and do some case cleanup while I'm waiting. The new headphone jack is mounted, and I put new wires on it. Okay, now I'm going to attack this crud on the front panel with some solvent targeted at the adhesive. Okay, the front looks a whole lot better. There's still just the faintest hint, if you catch the light right, you can just see the slight outline, but I think that's a paint blemish now and not actual adhesive left over. Anyway, the color is more even and everything, so that's an improvement. Now the other thing I have to do is clean this guy, and I think I'm going to repaint it, which means probably another trip to the hardware store and clean these grungy knobs up. Alright, so here's the piece I made. It doesn't need to be painted, it'll all be inside the case. And the objective is to replicate this guy so the mounting hole sizes and spacing is the same, but the actual RCA jack doesn't have to fit through this hole. Only one of these guys does. So that's what it looks like from the back, that's what it looks like from the front, and it should fit through the hole in the case just like the original one. And I did verify that this one has the ground side of the connector going to this mounting plate that does touch the chassis, so it's not isolated, so this will be electrically the same thing. And also the overall width is the same, so should work out fine. Okay, I've done all the restoration I planned to do. Unless something just doesn't work, then I'll have to do more. I decided to not put the fuse way over here. That would run the AC power too close to the low voltage input circuit. I wanted to avoid that, so I fit it over here. It's kind of close to the transformer, but there is enough clearance for the voltage, and for good measure I glued in a piece of Mylar as an insulator in case the fuse holder gets twisted or something and comes in contact, or physical contact but not electrical contact. I've got new wires running to the terminal board where the old fuse used to be. I have indeed replaced the RCA jack with a fresh new one. Looks good there. And I decided to trash the old connector because the screws were kind of grody on it, and I bought a few more of these anyway just to have in my parts bin. So it's exactly the same as the original, except for this one's kind of a fiberglass material, where the first one was just phenolic, so it's got a lighter color. But otherwise it's, I think, off the same stampings and everything that Keystone made way back then. And I also realized that these wires were solid. I hate solid wires and things like this, so I replaced the two speaker wires from the circuit board up to here, and then have fresh new wires running to the headphone jack. And the shielded cable is in good shape, I think, so I just soldered it to the back of the RCA. And I've cleaned the knobs. They're pretty clean now. And also the top of the case, but I could not find a matching paint, so I decided to leave it alone. So I'm going to do a sanity check here and see if this thing has any kind of operation. Okay, the amplifier's powered up. It makes a little hum for about a half a second when first turned on. I think that's just while the filter cap charges up. Or maybe a couple of the interstitial capacitors get charged to their stasis value. So I have both of these speakers wired in series, so I have an 8 ohm load. I have the output of my good old HP signal generator going to the input, just clipped on, and it's set to about a 200 hertz right now. Well, let's turn the volume up. see the tone control work. It's a high frequency cut. Tone control seems to be working. One kilohertz. I'll turn that down a little bit more here. A lower input here. It's kind of crackly on here. So let's crank her up to 2 kilohertz. 3 kilohertz, 4, 5, 6, 7, 8, 9, 10 kilohertz. Starting to call the dogs in the neighborhood. Let's go to down to 2 and go up to 20. Well, either these frequencies, these speakers can't kick out any higher frequencies, or the amp is rolling them off. There's really nothing I can hear at 20 kilohertz. 10 kilohertz is basically there. Again, maybe if I turn the tone up all the way and go back to 20 kilohertz, I just start hearing something around 14 kilohertz. Well, these are not full range speakers. They don't have tweeters. They don't have anything really except, but I suspect the amplifier is rolling some frequencies off too. Seems like there's some resonances in that. Alright, we're giving it a sine wave, and we're getting a nice clean sine wave pretty much on the output. And the input I'm giving it is about 2 volts peak to peak, which is kind of a lot. I should probably take the amplitude down to about 1 volt peak to peak. And the amplifier's turned pretty far down. So right now we're at about 4 volts peak to peak here, but the amplifier turned about halfway up. And it's not really the voltage that's important, it's the current. There's kind of a high frequency buzz on this, but I can't see it in the waveform. It looks pretty clean. The amplitude isn't modulating, but it should be floating around 0 volts, and it is pretty much. Anyway, let's look at the waveform with a triangle wave. Looks pretty clean. Square wave, it has that higher frequency, higher overtones. The sine wave switch on my generator's a little iffy, that's why it's bouncing around. So it's working. The only thing that concerns me is that this heat sink down here is just on the edge of not wanting to hold my finger on it. That's really hot for something that is just driving a couple little speakers at moderate amplitude. I'm not sure if that's normal for this. I am getting negative voltages. They're symmetrical, so both transistors are working. I don't know, maybe that's just normal for this thing. Some Heathkit stuff was designed to run pretty hot. Anyway, let's get enough of that. It's annoying. Anyway, so it's basically working. I might want to get my hands on a couple of replacement transistors for this, just to see if it makes any difference. But For the occasional use I'm going to give this, I'm not going to worry too much about it at this point in time. Now I'm going to turn it back on. Get that little hum for just a moment. Just looking at the voltage across the power supply capacitor, the main one, first stage, and 0 volts is at the bottom. We're at 5 volts per division, so it's 15, 16, 17 volts with a couple of volts of ripple on it. Not unexpected, really. Okay, this is across the second stage filter cap, that is, and we're still at 5 volts per division, 0 being down here. I'll double check that. Yep. So we're floating around 12 volts, and I don't see any real ripple on that, at least nothing immediately obvious. It's supposed to be nominally 14 volts. Anyway, I think it's working. I'm not really going to worry about the warm heat sink for the kind of occasional use I'm going to give this. It's not like I'm going to be listening to music on this for hours. I'm thinking that such tinny little speakers, which have almost no weight to them, I think this thing that makes it look like there's a huge magnet is actually just a piece of sheet metal covering up a much smaller magnet to make it look like there's a big honking magnet on the back. There's just no weight to this at all. You notice it may not be that obvious in the video, but the center dome on this thing is pretty much off center, which doesn't hurt anything. It's just that, you know, it's not a very precision operation wherever these things are made, and you know, you have to look at it at the right angle, but it's also pretty far off center. You can see the left side of this cap relative to where the right side is from where the frame slopes in. It's not even centered. I hope these things work. I haven't even tried powering them up. Anyway, I don't think this needs a big, thick, heavy wooden cabinet. It would be ridiculous for these. If these were in a transistor radio, it would just be a thin plastic cabinet and it would be fine. I also don't want this thing to look any worse than it needs to be. And first I thought I would give it a sort of utilitarian look, but then I thought, hey, it's a speaker cabinet. Why not make it look a little better? So what I'm thinking here is I've got this piece of whatever this oak or something, scrap left over from making some shelving. I could resaw this thing and get 2 decent thicknesses for the side panels. Plenty of wood on there to do that. And then I've got some, well, this is 1/4-inch craft plywood, and this is some 1/4-inch cabinetry plywood. It's just filler with veneer on the outer edges, but it should be fine for something like this. And then I can either make the rear panel out of some of that or out of this piece of resawn pine board, which is again about 1/4 of an inch thick. So I have enough scrap wood around to make this thing. I just need to figure out the actual dimensions. Okay, I have my design figured out. This is going to be the front panel. It's going to be exactly the same width as the specifications for the AA-18 amplifier. I hope those are correct, because I won't receive that till after I've done the woodwork on this. I've got the 2 speakers mounted in here. I'm going to have a little front panel on the side because of the variety of types of signals I might expect to connect up to this. If I'd had more space, I probably could have done something with screw terminals or banana jacks too, but I decided I didn't really have room for that. So I might be troubleshooting a piece of stereo audio equipment and want to run both channels over to RCA jacks. So I'll have a pair for receiving a stereo signal, and then a single jack for mono, also an RCA jack. That'll match the negative connector on the input of the amplifier. And then a stereo phone jack for 1/8" tip ring sleeve jack or plugs, and that is also to receive things like the output of MP3 players and things of that nature. Because the amplifier is only a mono amp, I'm going to have to do some passive mixing. And there's my little schematic. These are the two stereo RCA jacks, the mono RCA jack and the 1/8" stereo phone jack with its tip and ring, or right and left contacts there. All the grounds are tied together. Then there's going to be a single RCA jack on the back that'll match the one on the rear of the amplifier, and its ground is also in common. Then the mono RCA jack on the front just goes straight through to the rear, so it's just a convenience jack, so I don't have to reach around the back of the amplifier to connect up signals. And then for the ones that are stereo, I've got 10K resistors forming a passive mixer to this, essentially a bus, and the same thing here. So that's a fairly conventional way of doing a passive mixer on line level signals, and that should be pretty easy to wire up. One thing that I was wondering about here was, I was really kicking around whether I needed to even worry about what acoustical type of speaker cabinet I was going to have here, and I decided a simple sealed cabinet was good. I wasn't going to try to go with, you know, a bass reflex design or anything like that. It's ridiculous, I think, with speakers like this. It's not for high fidelity, but you do, at least my understanding of it is, you do want to have your speakers baffled or something so that sound coming off the rear of the speaker cone is not audible in proximity to sound coming out the front. And if you just have a speaker sitting like this, it's never going to sound as good as it should, because of weird cancellation effects depending where you are around the speaker, where the negative sound wave coming off the back and the positive sound wave coming off the front could interact with each other and cause weird results. So the main reason you put a speaker in a cabinet is to deal with that one way or the other. And the simplest way is just to baffle it. So you know, have a big piece of wood or something, or a hole cut in a wall or a cabinet, and bolt the speaker in there, and the sound waves on the back can't get around to the front anywhere where the listener is likely to be, at least not without a lot of attenuation. And that's, you know, speakers that people mount in the bottom of kitchen cabinets or in the drywall of their houses and the ceiling and things are basically doing that. The other way is to put it in a box that's just sealed up, no holes in it whatsoever, and it shouldn't be a problem with a really small low power design like this. At some point you can get into damping issues and all sorts of other things, where you want to let that energy out from the rear, and then you can go into various baffles and portings and things like that. I just decided that was going to be ridiculous for this. Plus it would take up more room. On the other hand, I'm going to have 1, 2, 3, 4 perforations on the front with open jacks, which will provide little leak holes, and again, I don't think that's going to make any noticeable difference. And then of course on the rear there's going to be another one for the rear RCA jack. So the idea is everything's going to be 1/4 inch something or another. I'm going to use my pine board for the front, mostly because I think it'll take little screws for the speakers better than this cheap plywood, so better for speaker mounting. And about 1 inch wide on the right hand side, I'm going to have the little input panel, which is just going to be like I did on my top view here, it's going to be recessed in about 1/16 of an inch, and then a hole cut through it the rest of the way, so that the jacks, which are intended to be mounted on sheet metal chassis, can go into something thinner. But I think I'll just glue this panel in there. If I need to remove any of them for some reason, I can still reach through the back and you know, pull them out or redo the wiring or whatever I want to do. The single jack on the back will be on another 1/16 inch piece of aluminum or something, but this one won't be recessed. It's not as cosmetically important being around the rear. And then a hole cut through, just a circular hole for the jack to fit through. This is all scale, so it would be kind of like that, and these guys will be kind of like that. I realized in my pile of jacks I didn't have any stereo or tip ring sleeve 1/8 inch jacks. This one looks like it is because it has 3 terminals, but really it's got an integral switch, so that's what that's for. So I had to hurriedly go on Amazon and place an order for a bag of 10 of these things. Unfortunately, that'll slow down completion of this project because I have to wait. You know, tomorrow night's New Year's Eve, and with all that in the weekend, it's going to take an extra couple of days for stuff to get here. Anyway, not a big deal. I'm planning on making the top and the 2 sides out of this piece of oak board here after resawing it and planing it to thickness. All of them are going to be cut front and rear for inlaying the front panel and the rear panel, so they'll be cut in, and then they'll the bottom, top, and the sides will be bevel cut so that they fit together like picture frames. And because of the thinness of the wood, I might put in a little reinforcing piece glued in to the corners just to make it a little stronger than those. Of course, once I glue in the front panel, which is my intention, that will make it a lot stronger right there too. And the rear panel I want to be able to take out in case I want to revise the wiring or do something else. So that one will be removable instead of glued in, and because it's just a narrow little lip there, I do plan to put in some sort of rails around the opening that I can put screws into. That's sort of a last minute detail that I'll put in once the rest of it's made. So at least I know what I'm going to do, and I have things that'll work with the dimensions of the wood I have. This piece of pine board here is exactly the dimension that I need here for the inlaid front panel, and it already has good surfaces, so I won't need to cut it on those sides. This one itself was resawn. You can see all the bandsaw marks, and I may not even worry about that because that's just going to go towards the back. I think this is already 1/4 inch. If it isn't, then I will plane it to get it closer. It is about 1/4 inch, so I think I'll leave that guy go. And I'm going to paint this one, so the cabinet will have probably a stained oak sides and top, and then a black painted, probably matte black or something, front panel that's again inlaid in the front. And the back is going to be made out of this let's see, yeah, this 1/4 inch craft plywood. Again, it's just big enough to work. And then I'm going to use this piece of cabinet, 1/4 inch cabinet plywood, which again is just big enough to be used for that purpose. So the only one that's going to be any work to do will be cutting this guy down into pieces, resawing it, planing it, beveling it, and gluing it up. Be like making a picture frame. Okay, I've got this piece of oak marked up here. This wet spot here is when I was trying to get a label off. I used some label and adhesive remover, which is still evaporating. So the piece here, up to those double lines, will be the top. And then this area here will be the two sides. Of course, I have to resaw this whole thing and plane it to get the requisite thicknesses. But first I'm going to trim off this excessive width down here. I'm going to leave this little part until after I resaw and plane it, just so the pieces are a little longer. And I don't think I'm going to cut it in half here until after planing. It'll feed through the planer better if it's longer. My bandsaw is not that good at resawing bigger boards like this, especially the harder woods. I could see I was going to have too much blade wander on it to do a good job. So I'm going to do it on the table saw by flipping it around, sawing halfway through, then flipping it around and sawing it the other way. I don't like doing this, but it's the only way I can think of getting this done. It gets nice and hot in there when cutting that deep into a board. That's the main reason I don't like doing that. Well, it worked. Have to be really careful doing that. Now to the planer. I hadn't realized how full my chip bucket was getting, right up to the top. had planned to flip the notched ends up on edge to cut those off, but I don't have a permanent zero tolerance plate for this saw, and so I decided it was too close and I didn't want to bother with that, so I just decided to do some parallel cuts to open that out to the end. But I forgot that I'd already adjusted the blade height to go in this way, so the first cut I made went almost all the way through and left the piece a little floppy here. So before I go any further, I'm going to fix that by flooding it with epoxy and then resawing this end, and then I can do the other ones normally. I don't want to have to remake this, plus I don't think I necessarily have enough scrap. Okay, that slot is nearly filled to the top with epoxy. I'm just going to have to decide that that's all I'm going to do on this today, and resume tomorrow, New Year's Eve day. Hopefully I can get all these pieces notched out and beveled, or is it mitered? I can never remember. And glued together into the four sides, not including the front and rear. It being winter, it's a little cool here in the basement workshop. The epoxy is set up enough where it's not runny anymore, but it's still a little soft. Not something I can saw into yet to clean up that groove. So I've got it propped up in front of one of my heater fans, so I'll let that go overnight. Meanwhile, since I'm down here, I think I will cut the other pieces. Okay, so now I've got these cut out like this. That's for inlaying the front and rear panels. This piece of wood is actually a little thinner than 1/4 of an inch. It's this oak surfaced or oak veneer cabinet plywood, and it's some metric size. It's a hair less. That's why the inlay is a little deeper, but it should still be fine. I knew that, I just didn't make any allowances for it, or I didn't adjust it to be right down the middle. So that's all good. I'm going to clean these up just a little bit by dragging a chisel along those edges just to take the tiny little burrs off. The problem is that the teeth on the saw are not completely flat, they're at a slight angle, so unless you do a lot of passes, you're always going to end up with just a little bit of rippling on there. You can kind of see it. Just so the inlaid pieces fit in better, I'm going to clean that up. Okay, the next morning the epoxy's dried. It caused the relatively thin wood to warp a little bit this way. The easiest way to fix that, I don't care if the inside's warped, but I put it on the sander and flattened it out a little bit on the outer edge. Now I just have to recut that groove in there. Okay, all these pieces are now beveled. And so on. Okay, proof of concept here. The pieces are fit together very roughly here, so they're not joining up perfectly, but it shows that all the parts are basically coming together. And I have the desired 7 3/4 inch by, what did I say, it had to be 3 3/4 inch tall. Looks about right. And 4 inches deep. So no screw ups there except for the one with the slot depth that I fixed. And I've arranged for that spot, which has a slight discoloration, to be on the side furthest from where I'm going to be and towards the back. So time to glue this thing up. I'm debating whether I should use wood glue on this or epoxy. Epoxy might actually be better. I don't know. Okay, 2 band clamps holding the whole thing into alignment. I do need to check for square, even though that usually does a pretty good job. Yeah, it looks like it's doing just fine. Yeah, right on the money. Alright, I've cut out a 1/16 inch deep recess or inlay. There's a little bit of burr on this I'll have to sand off, but it did a pretty decent job. Really the only way I could think of doing that was on the router table. Not a job for any of the saws. Doing a quick test fit of the front panel in there, and it goes in fine, except it's just a little bit proud. It sticks up just a hair, so I think I'm gonna have to plane the back of that, which could use a little bit of a planing anyway. Just take it down a hair and then check it again for depth. Okay, after planing, it is now flush. And I've got my nice little inlay in there for the jacks to go through. Now I got to start cutting this guy out. Now I've got to cut out the 2 holes for the speakers. I'm going to slot this area here, and I'm going to use the same Forstner bit just for convenience as a starting place for the scroll saw to get its blade through. I forgot to mark my cut line. Alright. I'm not using the foot on here because of the close quarters, it would just get in the way. Plus I've got a fairly large piece I can hold down. Okay, here's the back panel. I've moved this off the table saw so I could use the table saw. And it looks like it fits in pretty nice. I've got just a little slop around the edges as I wanted to, so it doesn't fit too tightly. Let me see if it fits any better the other way around. No, I like the way it fits better the first way. And this is definitely the better side out. Good. Okay, I have the back panel with primary cutouts for the RCA jack that's coming out of the mixer and going to the amp, and then I have, it's going to be a matching screw type speaker terminal board for matching the one that's on the amplifier. Good old Keystone electric part that's still made after all these years. Apparently unchanged. So it's going to go in this position. So I think what I need to do now is make the pieces that will glue in for this to screw into. So these are just about ready to drop in there. Just a hair too long. Need to sand them down a bit. Okay, I've got the strips glued in around the edges. They don't need to go the whole length. I was limited by the scraps I had, but that's fine. It just needs to give me enough places to put screws through to hold the back firmly in place and still get my hand through kind of to do any work in there I need to. Alright, I've marked my speaker locations and the holes, so I know exactly where those are going. I'm not going to do a grill on this, as I probably already mentioned. I kind of like the blue cones on these anyway, so with just some black paint on this, and then put those in from the rear. Looks like I need to get some washers under the corners. It's unfortunate that these things are made so cheaply. It's really thin sheet metal on there. I probably could hold them down that way, but I think I'm going to stick a washer under each corner. So not much more to do on that. And I'm going to save the sheet metal work probably for later or tomorrow. Okay, the glue is pretty much dried on the two sides and the bottom and top, and I've just put the front panel back in just to see about accessibility. I want to make sure I don't need to leave provision for removing this at some point, but I think I can still get my hands in there. If a little bit awkwardly, at least I can get at the back of these if I need to, because I plan to glue the front panel in there so I can, you know, get down there and hold a jack in there while I tighten the nut on it or so on. So I think that ought to be okay. Now I can get straight in the back of these things with a nut driver for the RCA jacks. And a screwdriver will reach the screws on those, so that's good. Okay, I have some 1/16 inch thick aluminum, scrap from another project I had, and I've got it marked for where to shear it. Alright, let's see how that piece fits in there. Looks like it's just about perfect. Matches up nice and flush with the front. So the inlay was done correctly. And then I've got this other little piece that will go on the back right here and hold the RCA jack. And it's set up to be the same width as the board that has the speaker terminals on it. And yeah. Alright, time for staining. I've sanded this guy down along the edges and all the outer sides. I have to wait a while to do the other ones because there are still some uncertainties with things I have on order. I don't want to go and put paint on it, for example, or glue things to it until I'm sure I have all the dimensions right. So I can do this part. I've got some Minwax Classic Oak 370, which badly needs to be stirred up. Hopefully it's still good. Battery just went dead. All four sides are oak, but it's a different oak on the sides and the top. The bottom being from some oak veneer plywood, and the sides and top coming from a solid oak board. Just checking for runs, evening out the parts that are going to show. A little bit of oxygen. All right, it's sitting out here to dry. I would like to put a heater fan on it, but I think I'm going to wait to do that till I get back from the New Year's Eve revelries. I don't want to leave it running while I'm away, but yeah, I think it'll come out all right. I probably won't even give this a second coat. It's such a minor thing. Maybe, I don't know. We'll see how it looks when it's dried. Actually, after sanding, it looks pretty good. I don't think there's any need for another coat of varnish on this. I proclaim this ready to be used. Okay, I'm going to be drilling pilot holes for the screws to hold the speakers in. I have to make sure I'm drilling it from the back. My initial plan is to put screws in from the rear, but not to the point where they protrude through the front. So I've got the drill set up so ideally it'll go almost all the way through, but not quite. That's the goal anyway. And then I'm going to have to grind the tips off the sheet metal screws slightly, make them just a bit shorter. If these ever fail, I still have the recourse of drilling them through and putting short screws in from the front and putting nuts on the back. That'll be less attractive. Let's see how it goes. Nothing poked through. So far, so good. Okay, I have the back taped on temporarily. I've got places for screws to go through into those strips I glued in around the periphery. So I'm going to drill pilot holes for the screws up until the blue flag. And then once I've done that, I'll remove the back panel and drill the holes larger as a clearance for the screws. So now I have the little piece of aluminum that'll hold the rear RCA connector. and I need to drill out the clearance holes for the 2 mounting screws. So I've got the drill appropriately in there. It's too small a piece to hold with my hands, and it can easily get away and whip around and do some damage to itself or me, so that's why I had it in the vise. But there's nothing supporting it from the bottom, so I'm hoping that it'll hold here and not make things worse. Was drilling pretty gently there so that I didn't push it down out of the grip of the vise, and that worked out pretty well. On the front panel aluminum, I already have the 3 holes drilled for the 3 RCA jacks, and I just have a pilot hole for the 1/8" stereo phone jack. I don't expect those for 2 more days, and I don't really want to wait. I want to get these things painted. So I've got a old, like a Radio Shack monaural, in other words, tip sleeve jack, and I think it's a fairly standard size, so I'm going to drill it out for that size, and hopefully it'll work. Otherwise I'll have to stick a washer in there or something. Now I just have to do a light sanding of the front of this, and I can paint it along with the other bracket. Alright, I have both of those pieces sanded and wiped down with isopropyl alcohol, and I have them offset from the craft paper with some of these drywall anchors. I have probably about 1,000 of these things, so I tend to use them for things like this to set things up on, and they have just a very tiny point so they don't leave much of a blemish, even if the side they're poking into has been painted or varnished. And I was going to paint these with a contrasting color, but I've decided to paint them with the same color the wood's going to be painted. In other words, a satin black enamel. Okay, there they are. Okay, there are the 2 metal plates painted. Came out pretty good, especially the front one. Alright, there are the front and rear pieces ready for painting. I've got them sanded down as much as I can, get them as smooth as possible. I'm using this combination satin enamel. It's a paint and a primer. It's not intended to be used as a primer and then sanded and then painted. It's really supposed to do it all in one. So I'm hoping I don't have to paint it, then sand it, then paint it again. I might have to. We'll see how it comes out. Alright, well, I've given these a first coat. And I wasn't too happy with the way it came out, especially this one. When I was trying to shoot the paint around the inside of the speaker cutouts, I got too much paint around the holes on the front surface, and it looks like it's going to make ripples and stuff, so I'm going to have to sand that down and then shoot it again, at least that panel. The other one may be okay. Alright, I did decide to sand them. I sanded this one, the front one, a lot more thoroughly because of the buildup and the ripples, and the other one I just give a very light sanding just to remove high spots and the usual little burrs and things that appear after a first painting or a first varnishing. So I'm going to give it another shot, and then probably, at least on the front one, give it a third shot just to build up a little thicker finish. Alright, I've got a third coat on it since it's been resanded, and now I finally got the finish on there I want. I was worried that I wouldn't be able to resurrect it, but it seems to be okay now. I'm pretty happy with the finish I got on the rear panel. It shows just a bit of wood grain, but it's not real obvious, and it's got a nice smooth finish. And I've got all these holes drilled in here. I want to see how it looks with this rear panel in place. I think that's a nice look. And I've got some black, what do they call it? It's not anodized, it's like a black chromate or something like that, I forget. Anyway, those will be the screws I put on from the rear. So those should look okay. And I'm using similar screws to hold the jacks on the back. So that's coming out well. And I expect with the identical finish on there, on the front side of this, it'll look similar. Now this side's going to get glued in, and there's one step I have to do yet. I have to try to sand this a little bit because I didn't mean to varnish these gluing surfaces. It's not something I intended to do, so I'm not sure if I can scrape that a little bit. It may be that the glue adheres to the stained and varnished surface all right, but I don't really want to chance it, so I'm going to see if I can do some remediation on this. Well, as I was dusting or blowing off the dust I got from sanding along these inner edges, I dropped the darn thing, and my concern about how strong these joints were with such thin pieces of wood at the bevel, it did pop that seam. It stayed together, but it's loose, and I couldn't really get new adhesive into there, so I just propped it up in my table saw here and filled it with a thick bead of epoxy, and that will stabilize that corner. But the more I think about it, I think I can do something even better than that, and that is cut some little strips of wood, maybe 1/8 of an inch square, and then glue those into each of the corners as reinforcement. I think that'll make a big difference, and it won't get in the way of anything else, so I think I'll still cut those up. Okay, those 3 pieces have been made. It'll be a lot neater than what I did for this first joint. I just need to wait till that dries and then glue them into the other corners. But the epoxy, I can probably wait about 10-15 minutes between each one before I flip it over to do the next corner, get it done within an hour. Okay, there are both panels. Got a nice even finish on the front panel. And I think it's probably about time to figure out what I did with the piece of aluminum that goes here. There it is. And glue this guy on there. Looks like the finishes match pretty well. Okay, the input panel is now epoxied to its inset area on the front panel, and I just have it blocked here because sometimes these things tend to slightly skate out of position riding on the epoxy. I don't want to squish it down too much because then some might wick up through here and it would mess up the finish, so I have it just setting under its own weight so we don't get a lot of squish out, and it looks like there won't be any, so that should come out alright. Okay, the next morning I'm doing a test fit of the front panel. I think it's looking pretty good. Fits in there perfectly. Now I just have to glue in that last corner. Well, a dilemma here. I've tried to get these screws to go in there, and they don't want to start with the tips ground off, which I needed so they don't poke through the front. So I tried opening the tops of the holes a little bit to help them get started, and naturally they don't want to start that way. So I'm very close to just using these black button head, black anodized screws in from the front. I'd still like to avoid that. It's just right on the hairy edge of deciding one way or another to do this. I figured these would have enough grip on them. If I do it like that, there'd be enough grip going into the holes to hold them in place. So I think I'm going to try to open them up just one more time so there's less of the thread going into the holes. And if that doesn't work, then plan B, I'm going to have to drill them through and use the black button head screws. Well, I gave it a good try, but these washers here, for one thing, are too thick, and the speakers are not really up against the panel, and also they're trying to poke out through the front, even though I took great pains to make sure they weren't that long. So this idea sucks, even though it would have been the best cosmetic idea. So I'm going to have to go through with plan B. Okay, bolts are in from the front. I've put my washers with flatted sides here just to support the thin sheet metal, distribute the force just a little bit more. I put a small split ring washer on there just to help prevent the nuts from unwinding, and now the nuts go on. Alright, that looks acceptable, I think. I can tighten these down, but this front panel is fairly thin, and it's not even plywood, it's just 1/4 inch thick pine board. And in retrospect, I probably should have used plywood for that. But that's alright. It tends to warp the front a little bit when I tension these down to the point where I don't think they'll rattle or anything like that. It'll be a lot stronger once it's glued into the frame. So I've just left them, I backed the tension off on the screws enough that it's unbowed again, and then I'll glue it in here and tension them up just a little bit, just enough so they don't rattle or buzz when it's operating. But it's coming out to look fairly attractive. I made a bit of a stiffening, well, a stiffener here. The idea is that it'll go down below the speakers and sit up against the front rail and just add a bit of stiffness. Okay, that's installed. I don't know if it'll do any good, but I don't think it'll hurt. It rests against the front board, and then on fairly large tabs it's screwed between the speaker flanges and the front board. Okay, I've wired up the passive mixer. Not a horrible job. I could have done a little neater. The single RCA input, that's the one in the center of the picture, just goes straight to the two buses. The ground bus is the bottom one, and the signal bus is the top. I consider that to be the primary input, so it doesn't have any resistors. Plus it's the mono one. Now we have two more RCAs up here, which are for stereo signals coming in via the RCAs. If I want to be able to listen to both channels at once, there are 10K resistors going to the input bus. So that allows the two signals to be different without actually shorting them together, but yet mixing them. The input impedance on this amplifier is, well, the input signal is impressed across a 500K volume potentiometer, so the 10K here is small enough to be negligible. But from the amplifiers driving from whatever these signals come from, any difference between them gets dropped between these two resistors in series. So it's really like a 20K short circuit between the two signals, which should not cause a problem for anything. And then meanwhile, the stereo 1/8" phone jack has a similar treatment from its left and right, or tip and ring parts of the jack, a couple of 10K resistors going to the input bus. Okay, the wiring is done. I've got a bit of shielded cable running from the RCA jack to the signal and ground buses over here. And I've got red and black wires from the plus and minus terminals of the speakers there, or speaker inputs, going to the two speakers on the plus and minus sides, and then the so it goes in the plus of this one, the minus of this one goes to the plus of this one, and then the minus of this one goes back to the minus speaker terminal. And because these are facing each other, that's why the wire in between doesn't go like this. It's going from a plus to a minus. So I think I've left enough cable length that I can glue this guy into the front and stick this guy through this way, twist it around, get it outside the back, and then it'll just be a matter of doing the final assembly. Okay, I've got wood glue all the way around the front. Now I just have to drop the assembly through. And there I got it clamped up. I've put some popsicle sticks in there so that the clamps aren't pressing directly on the painted front, and also because it sets slightly inside the recessed or the inlay, so I need to have those to offset it a bit. Looks like this one slipped. I have to redo that one. There, that's better. So now tomorrow I can go ahead and stuff that. I've picked up some fiber fill at the craft shop. It's normally used for things like pillows and dolls and stuffed toys and stuff, but it's recommended on a lot of websites by people who build speakers as a good alternative to the purpose-built or purpose-produced speaker stuffing. I'm not sure these little speakers really merit any stuffing, but I'm going to put it in there anyway. Alright, the glue is dried enough to take the clamps off. And there's the back side of it. Difficult but possible to get at those connectors if I ever have to. Speakers are in there nice and tight. I need to have this upended overnight so those remaining blobs of glue have a chance to dry out before I close up the back. So I made up a little label for the back that explains what the speakers to be used for, how the speakers are wired, and that they end up being an 8 ohm load. Describes what the front panel jacks are from top to bottom. Mentions that the whole thing is a passive mixer intended for line level signals, and then it mentions that the RCA on the back is the mono line level output going to the amp input, and that the 2 screw terminals are for the speakers. And I've stuck little clear rubber feet on the bottom. Alright, I have the stuffing in there, and I'll just close her up. So there's that. Okay, there's the finished product. Okay, there's the amp speaker stack put together. Okay, this project is finished. I've got the Heathkit AA-18 amplifier and the newly built speaker sitting up in the position I intended for it. And I have the stereo line level RCA jacks connected through a cable to my Tascam DR07X, which just has a bit of random band recording on it. So I'm going to turn the power on. It's going to hum for a second, just while the power supply gets up to speed. And I'm going to turn the volume up to about half, tone all the way up so I'm not suffering from the high end. There we go. Almost no bass, as would be expected. That's the end of that clip. So, it's a success, it's working. I'm a little concerned about how warm the chassis heatsink gets just playing at moderate volumes, but since there's no discernible distortion or offset on the scope measurements I took, I think it's working properly. It's probably just normal for this design. Anyway, I'm not going to be using it a lot, just for occasional testing of things. So, success! Alright, even though this isn't really one of my main Heathkit equipment videos, I'm still going to do a quick look through the manual. This is a reproduction manual by manualman.com, and it does of course use all the same content of the original manual. So we have the table of contents. A parts list. Parts pictorial. There aren't that many parts. Starting the circuit board assembly. Continuing with some chassis assembly and more circuit board assembly. And completing the circuit board assembly here. And then preparing a shielded cable. Mounting the circuit board and the selector switch to the front panel. Mounting the transformer and the speaker terminals and the RCA jack and the headphone jack and the neon bulb. Wiring up the transformer and the rest of the chassis. Pictorial for that. Description of how to wire it up for 120 or 240 volts. How to install the line cord and the transistors that are heat sunk to the chassis. But buttoning up the case. Half a page of operation. General in case of difficulty page. 1 page troubleshooting chart. 1 page specifications. And a circuit description, a block diagram, chassis photograph, circuit board x-ray views, both viewed from the foil side, with and without components, and then the schematic diagram. Okay, let's just give a quick look at the schematic. So this is a single voltage power supply, or it's not a bipolar supply, I should say. It's a monopolar supply. So it only has positive power supply voltages relative to ground. And that's developed down here in a very conventional way. You've got the incoming AC line. One side of it's protected by a 3/16 of an amp slow blow fuse. The other side has the power switch. The neon lamp with its current limiting resistor is across that, and then the dual primaries of the transformer are wired in parallel across that voltage, so you get 120 volts here, 120 volts here. Transformer looks at it as if it's 240 volts. For the 240 volt operation, the two primary windings are connected in series, so you still have 120 plus 120 for a total of 240 applied to the transformer overall magnetic field. The secondary produces a center tapped full wave rectifier. So you've got a center tap transformer, center tap is connected to circuit ground, and then each outer side of the winding goes through its own half wave rectifier to produce 21 volts, and there's the large capacitor there to provide some filtering, although there's still some ripple at that point. Because you always have energy being taken from the transformer and put into this capacitor on each half wave, it is a full wave rectifier, even though it's doing it with just the two diodes, and it can get away with that because of the center tapped secondary winding of the transformer. And then we have a small RC filter here with a large value resistor and a small capacitance, the time constant of which is able to remove the ripple from this supply, but with the attenuation you get only about 14 volts here. The 14 volt supply is used for the first two stages of the preamplifier, and the 21 volt supply is used for the power amplifier. So let's take a look at the input. Because of its high input impedance, 500K, that's why it's able to work with things from phono cartridges through various microphones to line level signals to probably guitar pickups and things like that, quite a wide range of things. And it's very simply connected across this 500K volume control potentiometer, so the entire input voltage is dropped across that. And then we tap off of that, go through an AC coupling capacitor that removes any DC component of the input signal. And then we take the 14 volt supply, we have a 10K resistor and a 470K resistor and a 100K resistor, and that produces a bias voltage here, which is coupled to the base of the transistor through this resistor that holds the DC bias on this transistor at an intermediate point between plus 14 volts and ground. Then the AC coupled signal from the input is able to wiggle that around plus or above and below the DC bias voltage, turning the transistor on or off more or less, but it's always conducting some. It's just conducting more for a larger signal and less for a smaller signal. And that produces an output voltage here on the collector, and that is again AC coupled into the base of the second preamplifier. It also has its base DC biased with this resistor up here from 14 volts and this resistor to ground. So it's holding this at a DC level, and then we modulate that up and down with the AC signal coming from the first stage through this capacitor. This point here has a RC filter going to ground. So a relatively small value of capacitor, and then the 100K tone control, which just acts like a variable resistor. With both of these together, as frequencies get higher, this capacitor looks smaller, and this tone control starts to have more of a shunting effect. So depending how you adjust this, you either roll off the higher frequencies, or you don't, or you do some intermediate amount of roll off. And that's how we get the treble cut tone control. There is no bass or effect on bass frequencies or lower frequencies by this circuit. Then we have this pre-driver. Well, that's the second stage we already talked about, but it's not AC coupled. It from this point on is DC coupled, so it drives this output stage driver, which now operates off of the 21 volt supply, and it doesn't matter if there's some ripple on there, because the amount of voltage you're wiggling the output around here doesn't get anywhere near that 21 volts. Because of the DC coupling from this point on, the bias voltage, or the DC bias voltage established here, passes through this transistor, and it has the end result of holding this point in the circuit at a DC voltage level that's roughly half the power supply voltage. So it can go above or below that point about an equal amount. So the signal propagating through here gets coupled into these two transistors that are in a classic complementary symmetry emitter-follower circuit. So these guys are just basically doing what this is doing, but with more current. This being an NPN transistor, it responds to signals going more positive, and this being a PNP, it responds to signals going in the other direction. So you can drive both of them at the same time, but only one of them is conducting, depending on where the voltage is on the signal. When it needs to be pulled up, this transistor is turned on more and more. When it needs to be pulled down, this transistor is turned on more and more. And when you have a signal voltage of about 0, then neither one of these should be conducting. And that allows the the biasing to hold this point at about half the power supply voltage. So there needs to be some feedback here, and that's achieved by these resistors here. It takes this voltage at this point and feeds it back to here. So that's an AC feedback. Well, it actually is working on DC, but because this signal is varying, it's not AC, but it's varying, at higher frequencies you could get into an oscillation situation. And so this capacitor here is provided to shunt this resistor out at higher frequencies, thereby adjusting the amount of negative feedback you get here and making this a more stable amplifier at the higher frequencies where the oscillation is more likely to take place. This resistor here is a 0.51 ohm 2-watt wire wound, and it's really there, I think, to protect these transistors if both of them are turned on at the same time by a small amount, or they start kind of fighting each other a little bit near the crossover region. That allows the power to be dissipated in this resistor. Now ultimately we don't want to be feeding a varying DC signal to the speakers, we want to feed it an AC signal. So we have this capacitor here to provide AC coupling, and the DC portion of the signal is blocked. So while this signal here is really all above ground, it can't be below ground. It's going, you know, in whatever waveform it needs to be, but it's all above ground. By stripping out the DC portion, you get the same waveform, but now it's centered around ground, equally positive and negative. And then that's coupled directly to the positive speaker terminal, the other one going to circuit ground. And also we have the headphone jack here. It has the same ground as the common speaker terminal, and then the speaker output is coupled through these two 100 ohm resistors to the left and right channels of the headphones. And let's see, I think the only other thing I probably haven't talked about is this little RC thing here, which is again a high frequency shunt. It wants to make sure that we don't have high frequency oscillations going on, and if there are, it shunts them to ground, again providing more stability for the circuit. So this resistor here, I wasn't sure what it was doing, so I actually had to look it up in the circuit description in the manual, and it says it's sort of a bootstrap circuit, if you will. I'm still not clear on exactly what it's accomplishing, but being called a bootstrap, apparently it's helping get this thing started. Maybe if I pondered it more, I would understand it better. But it's a fairly standard amplifier of its class. No big surprises here.